Welcome to Zinnov Podcast, where we bring you conversations with eminent industry stalwarts and thought leaders from across the globe as they share insights on shaping the future of enterprise growth, AI, innovation, transformation, and more.
Hi, everyone, and welcome to another episode of Zinnov Podcast. I'm Vijay Hegde, partner at Zinnov. Today, I'm joined by someone who's been at the center of automotive transformation for over 2 decades, Naveen Kichili, Global Head of Software-Defined Vehicles and Cybersecurity at HCLTech. Naveen, great to have you here. Thanks for joining us.
Thank you, Vijay, and looking forward for a great discussion with you.
Great, Naveen. So, before I start, let me set a bit of a context. Um, So the automotive industry is going through what I would call a once in a generation shift, right? Uh, the cars are no longer just a mechanical machines with embedded electronics, or they are becoming more of a software first platforms. In fact, as we highlight in our joint white paper, by 2030, more than half of new vehicles sold in mature markets will be software defined. That's a massive shift. And it's not just in engineering, but in business models, validations, cybersecurity, and also in the monetization. So, Naveen, I would like to start here with my first question to you being you have been in this industry for nearly 25 years and you have seen the evolution from distributed ECUs to centralized compute. Considering all that aspect, why is this? Why is this particular movement is different? Why you believe the software-defined vehicles, not just another tech wave, but they are truly transformative? Can you share some thoughts around that?
Yeah, Vijay, and I love how you framed it in the intro because that's exactly it. We are in the middle of a once in a generation shift. If
Mm-hmm.
I boil it down, SDV is transformative because it changes the vehicle from being something you manufacture and ship to something you launch and keep improving. And that's a huge mindset shift. For
Mm-hmm.
decades, industry worked like this. We design a vehicle, we freeze the requirements, we build it, ship it, and then we hope we got most of the things right because after SOP, and what I mean by SOP is the start of production of the retail vehicles. As you
Mm-hmm.
know, the changes are painful. If something goes wrong, it's a recall, a service campaign, a dealer visit, and it's heavy. Now, the
Mm-hmm.
customers have a totally different expectation because of the digital products. They are used to the idea that what I buy today gets better tomorrow. So when they buy a car, they don't just want a nice feature set on day one. They want the car to age like a good app, not like a
Okay.
fixed appliance, right? And I've seen this shift firsthand. Like 10 years ago, software discussions were mostly around modules. Today, the discussion is platform level. How quickly can we deliver features? How do we keep quality high? How do we update safely? How do we secure everything? The other reason it's transformative is complexity.
Okay.
Modern vehicles are basically networks on wheels. What I mean by that is, too many ECUs, the one that you touched a little bit earlier, too many
Uh-huh.
variants, too many supplier stacks, and then we wonder why integration and validation take forever. Um, STD forces a more scalable approach, like fewer compute units, common services, standardized APIs, better reuse. And it's not only engineering, it's business as well. SDV unlocks lifecycle value, for example, features on demand, subscriptions, bundles, fleet
Mhm.
services, insurance integrations, but with a big caveat, right? Customers will only accept it if it feels like a real value, not nickel and diming. And
That's
and
true.
lastly, there is a cyber security. Once you are connected and updatable, security is no longer something you do at the end. It becomes a part of the product promise itself. In summary, overall SDV is transformative because it changes the product, it changes the engineering, and it changes the business model all at the same time.
Mm-hmm. No, perfect. Yeah, good. Thanks a lot for that. And also, one more thing I've seen in the paper, we outlined the six maturity levels. That's from
Yes,
software enabled to a full innovation platform, right? And
right.
the way I believe it is those that particular journey is not binary. It's layered, right? And here, I
Exactly.
want to understand, Naveen, is from your experience, how should OEMs think about this progression? Is there a particular sequence, and is that a right sequence, or it depends on where exactly are they today and how should they look into, and there's some flexibility that is needed the way they go through it.
Sure, Vijay. And this is very important because people sometimes talk about SDV like it's a single destination, right?
Hmm.
In
Hmm.
reality, it's a journey. And most OEMs are running it on a multiple tracks at the same time. I like to
Okay.
explain the maturity in layers because it's easier to visualize. Layer one is get the basics right. That
Hmm.
means modernizing your engineering tool chain, improving the software reuse, moving toward SL ways of working. Uh, Many OEMs are already here, but the catch is delivery is still program driven, tied to a hardware milestones. So
Hmm.
you're doing software, but not really being software. Um, Layer two is what everyone talks about connectivity and OTA. And I always say this OTA is not a button you install, it's an entire pipeline and a governance system. For example, secure vehicle identity, update orchestration, telemetry, rollback, stage deployment, and the release approvals, right? Because in software, you can push a bad patch to, let's say, 1,000 users and recover it. But in automotive, a bad patch can become a brand crisis, right?
Yes.
Um,
Okay.
and I have seen cases where 98% of the vehicles update perfectly, and the remaining 2% are in the edge conditions like a low battery or a poor network, or they have storage issues. And suddenly you are dealing with angry customers and warranty costs. So
Hmm.
the maturity is, can you do OTA reliably, repeatedly, and safely? Coming to the next one, layer three, this is the real pivot point, which is platformization. This is where OEMs build a common software platform like shared services, standardized APIs, middleware, and a very strong separation between the hardware and the software. The
Hmm.
KPI here is simple. How much software am I reusing across programs? If you are rewriting the same feature for every car line, you're not a platform yet, right?
Hmm.
Uh,
Hmm.
so layer four is architectural, which is moving toward centralized or zonal compute, like
Okay.
having ECUs, more powerful compute nodes, better isolation with virtualization, and a service-oriented design. This is what makes software portability and long-term scalability realistic. Um,
Hmm.
and the layer five is what I called a closed loop SDV, where fleet data continuously improves engineering. Virtual validation becomes a core part of development. Release becomes predictable, and the vehicle is managed like a living product for years. So the big message here is, the SDV journey is staged, but it has to be business led, and each stage should deliver outcomes like faster release cycles, better quality, lower integration cost, a better customer experience, and it should not be just, hey, we redesigned our architecture.
Okay, got it. And Naveen, here, you spoke about that 98%, and there are some cases where it may fail or it may get delayed. Similarly, do you see any biggest gap when an OEM looks into this? Do you see where exactly do they struggle? So moving from one level to other, or is it do they struggle in a particular level? Any examples on that front?
Yeah, so see, the OTA is a core part of any OEMs now. So
Mm-hmm.
as you can see, without naming names, lot of global OEMs have a lot of issues that they're trying to solve. They're able to solve the issues by fixing it, but it's taking immense amount of time to push that fix into the vehicles because their OTA process is not very strong and it's not very reliable. And it's not only OEMs, right? Because OEMs work very closely with multiple network companies where they need to make sure that the network is solid, and the vehicle should have enough memory to take those new softwares and be able to install. So that piece is, I would say, still evolving. Not many OEMs are very strong in that space, but every day they're getting better because now that the software is playing a very important role in every OEM.
Okay, got it. And another aspect that was discussed in the paper was on the the practical challenges from the legacy systems, right, and its complexity. And we have seen that
Yeah.
most of the OEMs today are sitting on decades of tightly coupled ECUs. Like they may have proprietary protocols like CAN or a LIN or some of the safety stacks, etc. Right? And
Right.
considering that, modernizing that without disrupting the current fleets, which is not trivial, right? I want to understand from
Right.
your experience, what's the biggest constraint? Is it the technology, the culture, the suppliers, or is it regulatory?
Yeah, a good question, Vijay. This is the part where everyone nods their head because the challenge is very real, as you said.
Mm-hmm.
The first big challenge is legacy, and I don't mean legacy as a negative. Legacy is basically the installed base and the decades of engineering decisions, right? Vehicles weren't built to be updated continuously, and the software wasn't designed with the platform reuse in mind. So the biggest enemy is the tight coupling between the ECUs, suppliers, program-specific implementations. The way to overcome that is not a big bang rewrite. The practical approach is incremental modernization. Like define a reference architecture, standardize the interfaces, and then modernize domain by domain. Almost like replacing the engine while the plane is flying. So you keep
Mm-hmm.
the vehicle stable while gradually moving the capabilities onto the modern platform. Second challenge is validation. SDV promises fast release cycles, but testing can kill that promise immediately. Physical testing is expensive and slow. So the industry has to shift toward virtual validation like simulation, hill, scenario-based testing, automation in CI/CD, synthetic data for long tail cases. Without that, SDV becomes we wrote the software faster, but we still ship slowly.
Okay.
The third challenge is operating model. Automotive is traditionally program based. Software needs platform thinking like product owners, shared roadmaps, release
Mm-hmm.
trains, and runtime operations. Because in SDV world, you don't stop at SOP, right? You monitor, you patch, you update, and improve for years. Uh, and then the cybersecurity and safety. Those are not optional, as you know. As vehicle becomes connected and updatable, the attack surface grows. OEMs need security by design, like secure boot, signing, SBOM, vulnerability management, threat modeling, plus governance around what updates can happen and how you roll them out safely. And on the safety side, you need traceability and change impact analysis that fit continuous delivery. And lastly, this one is often underestimated is a supplier ecosystem. Traditional supplier models weren't designed for continuous updates. OEMs need new engagement models, which has clearer API ownership, shared quality gates, security responsibilities, and the lifecycle maintenance plans. So the playbook here, Vijay, is modernize incrementally, scale virtual validation, evolve the engineering model, embedded security and safety early and align the ecosystem. That's how the SDV becomes achievable instead of just aspirational.
No, got it, got it. I think yeah, that's serious. I remember, I think in the paper also there was the analysis that was cited that over 60% of automotive cyber incidents involved data breaches, right? And
Exactly.
55% of that involved direct vehicle manipulation. So yes, that's
Yes.
quite serious. That's quite serious. Uh,
Yeah.
and the next one which I wanted to touch upon was if I look forward over maybe a next decade, what does a realistic SDV roadmap look like, right? Are we going to see a full centralization? I think something what you touched upon, or a hybrid model for a longer than expected. That is something what is expected.
Okay. Looking ahead, I see three big chapters in next decade. The first chapter, call it as next 2 to 3 years, is about building foundations and discipline. Like secure OTA becomes widespread beyond infotainment. Uh, Telemetry and diagnostic become standardized. Software inventory and compliance get stronger, and OEMs
Hmm.
get serious about DevSecOps. This is a phase where you're building the backbone, not always flashy, but it's absolutely critical, right? Uh,
Hmm.
then the 3 to 7 year chapter is where the architecture and the operating model really scale. Zonal and centralized compute becomes mainstream for new platforms. Service-oriented architectures mature. Virtualization and containerization become common to manage isolation and complexity. Validation shifts heavily toward digital, meaning simulation and scenario pipelines have become the norm. And then this is where AI starts showing up in a practical way, not like AI hype. But the real productivity improvements like generating test cases, analyzing logs, predicting failures, accelerating the root causes, improving the quality, this all can become the reality using AI. It's like moving from hunting issues manually to having a smart co-pilot in engineering. Uh, Now, the last one, which is the 7 to 10 year chapter, is where SDV becomes truly a life cycle driven. Vehicles
Okay.
evolve as platforms. Fleet data becomes a strategic advantage. Feature improvements and the quality improvements over the life cycle become routine, and the business models mature, like the subscriptions, bundles, fleet services. But the OEMs who win will be the ones who create the trust and tangible value, not gimmicks, right? Uh, Throughout all these chapters, cybersecurity becomes more intense. Regulation will vary by region. The winners will be the ones who can move fast while staying safe, secure, and compliant. And that's not an easy task. If I had to summarize the decade roadmap is really foundations, scale, and closed loop evolution.
Mm. Okay. Okay. Interesting. Interesting. And Naveen, if I look at the complete the life cycle or a roadmap, what you just spoke about, so where exactly do you believe the technology service providers such as HCLTech here comes in, right? So
Mhm.
is it from a you spoke about architecture, the modernization to OT readiness, right? So then the shift left validation you spoke about, right? Where do you
Yeah.
believe exactly the firms like HCL Tech can bring the biggest impact?
Yeah. See, service providers play a huge role here because SDV transformation is very broad, right?
Mhm.
It's not just one project that you complete and get it done, right? It includes embedded software development, cloud, data validation, cybersecurity, tool chains, operating model, all moving at the same time, right? And most OEMs can't scale everything internally fast enough while still running their current vehicle programs. What partners like HCL do is act as a force multiplier, which is scale, accelerators, and integrations. We help OEMs in a few key ways. One is platform engineering, like building common services, API standardization, middleware integrations,
Mhm.
building reusable components. So the next program gets faster and cheaper. Second is validation, modernization, which is building automation frameworks, simulation pipelines, scenario libraries, integrating testing into CI/CD. This is often where the biggest cycle time improvements come from. Third
Okay.
is cybersecurity, like building secure OTA architectures, SBOM, vulnerability management, threat modeling, penetration testing, and embedding security into the software lifecycle rather than bolting it on later. OEM should own the platform strategy and the product vision.
Okay.
Service providers should accelerate execution, reduce the risk, and bring proven accelerators. That partnership model is what makes SDV transformation feasible at scale.
Okay. Okay. And Naveen, any practical examples where this transition right delivered a measurable impact to? Is it possible to share any such example?
One example is an OEM that wanted to scale OTA beyond infotainment, but
Okay.
needed the confidence in reliability and governance because that's very key in the OTA. We from HCL helped build the secure pipelines, staged rollouts, telemetry-driven controls, and automated validation gates so updates could scale safely. Another example is an OEM where releases were blocked by validation timelines. We helped them set up a virtual validation approach, which is scenario based simulation and automated regression. So they weren't dependent only on a physical test capacity.
Okay.
Um, Another example I can talk in the cybersecurity is where we embedded continuous security testing and vulnerability response processes, so the OEM could respond quickly and safely when new threats appear. So there are some of the few of the use cases in the real world that we have helped some of our global OEM customers.
Thanks, Naveen. Thank you. I think that's been. Thank you for sharing those examples. I think that makes it more practical. And thank you for that. And thank you for your time for sharing this insights, examples, as well as your thoughts around how the roadmap looks like in future. And if I had to summarize, a few things which I noted down is one is SDV is not a feature upgrade, it's a structural reset. And
Yep.
second is it impacts architecture, validation, the security or a cybersecurity, the monetization also use touched upon.
Yep.
And also how, and it's quite important to see how OEMs think about this life cycle value. I think that's something captured quite well. And I think third, I think the thing which I noted is the journey is not about flipping a switch. It's about the staged
Exactly.
evolution across all the maturity levels. I think that's quite important. And thank you for sharing all this with us today. And thank you.
Thank you, Vijay, for the opportunity. It was nice talking to you.
Great, great. And for all those listening, thanks a lot. And you have access to this full joint white paper on the software-defined vehicles in the below link. And thanks for tuning in. Thank you.
Thank you for listening to this episode of Zinnov Podcast. Stay tuned for more such interesting episodes. You can listen to our podcast on Apple Podcasts, YouTube, Spotify, or any of your favorite streaming platforms.